All right, so 416, it was already isolated. My radical's already isolated here. I need to square both sides. So I am going to square the left-hand side, square the right-hand side. On the left, my radical just goes away. On the right, I need to FOIL. Yes? Now that I have it simplified on both sides, I need to move my variables and my numbers to one side because this is a quadratic. So I need to move the x and the 4 over. All right. I get a 0 over here. I get an x squared minus 5x over here. Solve by factoring. How do I factor that? Yeah, just take an x out. So I have x and x minus 5. My two options here are that x can equal 0 or 5. I need to plug it in, though. I need to check for extraneous solutions per the instructions there. So to do that, I am going to plug the 0 in. I have the square root of 0 plus 4 equals 0 minus 2. The square root of 4 does not equal negative 2. If I were saying x squared equals 4, positive and negative 2 would be an answer. But just straight up order of operations, I have all numbers. The square root of 4 is 2, okay? The only time it's negative 2 is when a variable is involved. You have to consider positive and negative. So 0 does not actually work here. Plug in a 5. Square root of 5 plus 4 equals 5 minus 2. That is the square root of 9 equals positive 3. That is true. So my only answer here is x equals 5. So first of all, what is a polynomial function anyway? You've been using polynomial functions. A linear function is actually a polynomial function. A quadratic is actually a polynomial function. For polynomial functions, a couple things that you need to know. Standard form goes from the highest exponent down to the lowest exponent, okay? So I'm going to write it with my highest x value, or as far as exponent goes, in the front, and I'm just going to keep going. So when they write it like this, don't let all the x's and the a's and all that confuse you. The a represents the coefficient. The x to the n is the highest exponent. And then you go to the next coefficient. N minus 1 means you're just going down. So let's say I start with x to the 5th. This one would be x to the 4th. This would be x cubed, x squared, so on and so forth till you just have a constant. Okay, that is standard form. A couple of terms here. Leading coefficient. Leading coefficient is the guy up front, the coefficient in the front when it is in standard form. Okay? Leading coefficient is when it is in standard form. It is the leading coefficient. Degree of the polynomial. They said the degree is n. N being the highest degree of any of your individual groups. Okay? So we're going to do a couple things here. We're going to, one, make sure these are in standard form. And we are going to then determine if they are a polynomial function at all. Just because it's not a polynomial function doesn't mean it's not a function. But we have to be able to write it in this form. All right? So the first one. This is a polynomial function. All right? We have little groups of monomials, as we would call them. This polynomial function is in standard form. You'll notice that it goes cubed, then squared, then 1, then a constant. That is standard form. So this will be an easy one to answer these questions. So for A, I want to identify some things here. It says identify the degree. Well, the degree is going to be my highest exponent. My degree here is 3. All right? It also wants me to identify the leading coefficient. The leading coefficient. Well, that's going to be the coefficient on my highest exponent, which is 2. Let's look at B. Let's look at B. All right, so the first thing I want you to look up here is a little caveat here. It says a polynomial function of degree n is a function that can be written in this form where n is a whole number. All right, so we're going to actually have to refer back to the technical definition of whole number. All right, a whole number, that is referring to a set of numbers, a specific set of numbers, 0, 1, 2, 3, 4, 5, and so on and so forth. It does not include fractions. It does not include negative numbers. Okay, so it's telling me that my n here has to be a whole number. What is the problem here with b?
Like an exponent that's -1, which is
I have a -1. A -1 is an integer, but it is not a whole number. If I were to give you -1 and say, what number set does this belong to? You should not list whole, all right? Because whole does not include negative numbers. So for b, this is not a polynomial function at all, okay? So this is just not a polynomial function. It does not mean it's not a function, but we are specifically talking about polynomial functions here. It's not a polynomial function. All right, let's look at this next one. First of all, is this in standard form? Highest exponent to lowest exponent. No. Are all of my exponents whole numbers? Yes. Coefficients don't have to be whole numbers, by the way. All right, so that square root of 2 is okay. But if I were to write this in standard form, I would want to rewrite it. That negative needs to follow the x to the fourth. Whatever's in front of it needs to go with it. So negative x to the fourth plus the square root of 2x, all right? Now, had that square root been on the x, which we're about to see, we would have an issue because that would have been a 1/2 exponent. But it's not, it's in front of it. So now it is in standard form and I can answer the two questions. The degree is going to be my highest exponent. What is the degree here? My leading coefficient is going to be the guy in front of that one. So it is what? -1. -1. All right. Last one. The last one, we have a little bit of an issue here. We cannot write this as a polynomial function because there are cases when in the radical you could. Like if this were a perfect square trinomial, we could actually factor it and actually take the square root and then have a linear or a quadratic or something. So if this were like x squared plus 4 quantity squared under the radical, those would cancel each other out and I would just have an x squared plus 4. But I am taking this whole group to the 1/2 power. This causes an issue, okay? It's not just an x squared to the 1/2 power. That would actually not be a problem. So if it was something like this, that's actually not a problem because that's technically that, right? Which is a polynomial. But I have a group to the 1/2 power. This one's not a polynomial. So for D, you would say this is not a polynomial function. I cannot even rewrite it as a polynomial. Now again, if they had a perfect square trinomial, like let's say they had x squared plus 4x plus 4 in the radical, why would that be a polynomial function?
because it's x minus 2.
It's plus 2, but yeah, this is technically x plus 2 quantity squared, square root, right? I can cancel those. I can actually simplify that to this, and that would be a polynomial. But the one that they gave me cannot be simplified. It's still something within the radical, and it's not considered a polynomial function, all right? So when you have a polynomial function, so the first statement is if you have a polynomial function, so you have to have a polynomial function, and it is in standard form, you can look at the leading coefficient and the degree and figure out what is happening at the end of the function, all right? And this is a chart that you need to learn, okay? So if it is odd, so let's say my degree n is odd. If my degree is odd, my functions are going to go opposite directions at the end. It's going to go down and up or up and down if it's odd, opposite directions. So then how do you know which way it goes? If it's odd and your leading coefficient is positive, okay, then it is going to go down on the left and up on the right. So as x goes towards negative infinity, which is what this is saying here, as x goes to negative infinity, so does y. Y also goes to negative infinity. As x goes to positive infinity, so does y. Y goes to positive infinity. So as I'm moving this direction, you'll see my y is going down. as I'm moving this direction, my y is going up. That is if your degree is odd and your leading coefficient is positive, okay? If your degree is odd and your leading coefficient is negative, it'll still be opposite, but it'll actually be the opposite of what you would think. As x moves towards negative infinity, y is going consistently to positive. As x is going to positive infinity, x is going to negative. So I look at it this way. If it is positive, it's going continually up. Pretty much it's going to start down and go up. If it's negative, it's going to go down from left to right, okay? It may make some loops in between, but eventually it's going to head down, okay? Even, let's say your degree is even. This is your exponent. Leading exponent is even. They're going to go the same direction. This is actually easier to remember. If it's even and positive, they are both going to go up on the ends. If it's even and negative, they're both going to go down on the ends, okay? Now, we're going to talk about what happens in between. But for now, we're just talking about the ends of the graph themselves, okay? So let's look at this. Describe the end behavior, okay? So you will always have two answers when you are describing the end behavior. You will have the answer when x is going to the negative side, so to the left side of the graph. And you will have an answer for when x is moving to the positive side of the graph, okay? And so then the first thing you need to do is write those two things down because you're going to answer two questions here. What's happening on the left side of the graph? What's happening on the right side of the graph, okay? So first I'm going to decide, are they going the same direction or opposite directions, okay? So I am going to do that by looking up here at my exponent. My exponent is odd. So refer back to your chart. My exponent is odd. So they're going to go different directions, okay? One's going to go up, one's going to go down. So I automatically know my answers are going to be positive and negative infinity. I just need to put them in the right places, okay? Then I am going to look at my leading coefficient. My leading coefficient here is negative. So that means they're going to actually flip-flop, right? So since it's negative, when x goes to negative, y is going to go to positive, all right? And so here, this guy is going to be positive infinity. And then because it's a negative and odd, when x is going to positive infinity, my y value is going to negative infinity. That is how you apply this test, okay? Made an error. I assumed this was in standard form. It's not, okay? Thank you, Kelsey. All right, so yes, I have to put this in standard form, and I was jumping ahead of myself as you all erase, all right? So same concept here. What is it doing on the left side of the graph? What is it doing on the right side of the graph? Does everybody see what I did there? All right? My first rule was it has to be in standard form. It was not in standard form, right? So put it in standard form. Key error there. This is still still even, yes? So they're going to go the same direction, both positive or both negative. But what is my actual leading coefficient here? It wasn't my -3. What was my leading coefficient? A +1. So it's going to follow this guy right here. And it's going to go to positive infinity and positive infinity. Okay, the zeros and number of turning points are key characteristics of the graph of a polynomial. If C0 is an x-intercept of the function's graph, the following statements are also true. So if you have a 0, then you have an x value that makes the equation 0. You also have that x minus that value is a factor, and whatever that value is called a 0 or an x-intercept, okay? X-intercept. So 0 means where it crosses or touches the x-axis. You have an intercept, okay? So then they talk about a couple things. The cubic function has 3 zeros and 2 turning points. When you have a turning point, it is called a relative extrema, relative min or relative max. It doesn't mean it's the highest or lowest point necessarily on the graph, but it means that within that turn, it's going to be a peak or a valley. All right, you'll notice like quadratics, that's what you're used to, parabolas. The turning point of a parabola is either the maximum or the minimum, depending on which way that turn is, right? The quartic, or the function to the 4th degree, in example 2, had 2 zeros and 3 relatives, 2 relative minimums and 1 relative max. If it would have had 4 zeros if it was translated out 3 units, is what it said, because of where the turning points were. So you start to recognize that zeros, or where the function equals 0, actually start telling you information about the function. The first rule that we see about zeros is a polynomial function with a certain degree has at most that number of zeros and at most one less than that extreme. Okay? So if you have a degree 5, the most zeros you can have is 5. The most relative max or mins you can have would be 4, one less than that. That's what that whole statement is saying. So if you look at example 3 in the book, it says state the maximum number of real zeros and relative extreme for this, and then find the zeros. So they've given us this function right here. First of all, they want the most you can have. So the most zeros you could possibly have here, the most zeros that you could have would be the degree. What is the degree here? 3. And the most extremes, the most number of extremes you could have here would be 1 less than that, which would be 2. Now they want me to actually find the zeros. Find the zeros. And right now, we are only talking about real zeros. We will get to imaginary zeros, all right? And you actually find that number equals. But now we're talking about the most zeros you can have. So we have this function. To find a 0, I want to find where the function is 0. Where is it 0? So in order to find out where it is 0, I set it equal to 0. Negative 2x cubed plus 4x squared equals 0. I am then going to be solving by whatever method I need to solve by. This right here, I'm going to actually factor it, right? So I would actually factor out a negative x squared, because that's just what I like to do. I like my leading guy to be positive. So if I divide this by negative x squared, I get 2x. If I divide this by negative x squared, and actually I can take out a negative 2. Let's do that. So we're going to take out a negative 2x squared here, because 2 also comes out of both of them. So I have just an x here minus just a 2 here. All right. Once I do that, I set each one of those equal to 0. So I'm going to set this guy equal to 0. And I'm going to set this guy equal to 0. That's just my rule of factoring. All right. Where does the first one equal 0? At x equals 0. And this one is at x equals 2. All right. Now, if you were to graph this function, all right, and they show you in the book the graphing of this function, you will actually notice that here it doesn't actually go through the x-axis. It actually just touches it. So if I look at the graph, you'll notice that here it actually got all the way there, but it bounced off and went back, and here it actually cut through. All right. We have something that we need to look at called multiplicity. multiplicity. So you may recall this from last year. This was x squared. So technically, that is a 0 with a multiplicity of 2. All right? Technically, if I were to factor this, I would get negative 2x, x, and x minus 2 as my factors. That's technically what I would get, right? If I were to do it in simplest form. This would give me 0, this would give me 0, this would give me 2. So technically, 0 is a multiplicity of 2 because I actually have 2 of them, all right? When you have an even multiplicity, this is what happens. It bounces. It hits the x-axis and it bounces off, all right? When you have an odd multiplicity, like this guy, it cuts all the way through, all right? And so your zeros do two things. They tell you where it touches the x-axis, but they also tell you by multiplicity what it does when it reaches the x-axis. So we know what's happening on the end with our degree and our leading coefficient. So we should know where it's coming from, right? And then the 0 tells us, do I cut all the way through and keep going? Or do I bounce off, okay? And so you start to get a picture of what's happening with your graph. All right, so let's look at the next one. So let's talk about this. The max number of zeros you could possibly have is 3. The maximum number of extremes you could have would be 2. When you actually factor this, you end up having 3 zeros. One of them just repeats, right? So you end up having 0, negative 1/4, negative 1/4, right? So I have 0 that's only done once, and I have negative 1/4, which is a multiplicity of 2. So now I'm going to look at a couple things on graphing this. What's my end doing here? Well, let's look. My exponent here is a 3. They're going to be going opposite directions. My leading coefficient is positive, which means they're going to follow what it does, right? Meaning on the left side of this graph, it should be negative infinity. And on the right side of the graph, it should be positive infinity, okay? So I'm going to be trucking along here from negative infinity, and I'm going to come up to negative 1/4. Let's say negative 1/4 is right here, okay? At negative 1/4, I bounce because it is a multiplicity of 2. So I bounce and come back down, but then at 0, I cut through the graph and keep going. How do I know I don't turn back around? Well, I would have to have another 0 to do that. I also know that I should go towards positive infinity, which means I can't turn back around. So I ended up having 3 zeros, 1, 2, 3, which was my max. And I actually ended up having 2 relative extremes. I bounced off the graph here, well, not pretty because it's kind of tiny. And then I came back down and had to turn somewhere. I don't know where I turned because I'm just sketching it so that I could cut back through my other 0. Does that make sense? So I cut through here, I bounced here. When it says sketch, it literally means sketch. It's looking for, do you know what's happening on the end? Do you know whether it bounces or cuts through? All right, that's what it's looking for with these answers here. Do you know what is happening with this function? And so when it says sketch the graph here, you're going to do some things. You're going to say, what is my degree? Are they going the same direction or different directions? Which directions are they going? So you're going to use this. Well, it's a even. They're going the same direction. And they are both going down, right? So both sides of my graph should be going down. So I already know what's happening on the ends of my graphs. It's going to go down somewhere over here. It's going to go down somewhere over here, right? Now I have to figure out what happens in the middle. That's where we're going to use your factoring here. I'm going to take out a negative x squared. I'm going to have 2x squared plus x minus 6. And I'm going to factor it, right? 2x minus 3x plus 2. And you can use your thing there. What's happening? Well, I have a 0. What's my multiplicity here? My multiplicity is 2, right? I have a 3 halves. What's my multiplicity? Just 1. I have a negative 2. What's my multiplicity? Just 1. So at negative 2, somewhere here, I'm going to actually cut through, right? I'm going to, beautiful, isn't it? I'm going to bounce off at 0, right? And go back up. And then at 1.5, I'm going to cut back through and go back down, right? So this is my negative 2. This is my positive 3 halves. So it's going to look something like that. I go up, I go back down to 0, I bounce off, go back up and turn somewhere along the way, and at 3 halves, cut back through. Okay? So your end values and your zeros help you see the picture that's happening with this graph.